Today our presentation will be about self-driving cars and the physics behind the uses of motion sensors within these driverless vehicles.
Self-driving cars will have a huge impact on future civilization. These mechanical inventions will ensure more safety in transportation, as they will help prevent the car crashes by human error.
The knowledge behind self-driving cars is very complex because there are so many different components that go into the overall technology. When they finally get self-driving cars on the road, it will be computer science meeting the road. Most of the automobile companies will have the driverless technology by 2020. These vehicles have GPSs which combine with other readings in order to provide the most accurate positioning. Next, the driverless cars have ultrasonic sensors in order to measure the distance of objects which are very close to the vehicle. Also, there are odometry sensors which help improve GPS information and a central computer which analyzes all of the sensors which operate the steering, braking, and acceleration of the car. Additionally, there are LiDAR sensors which are able to generate 3D maps, while laser sensors are able to find different range distances and can detect cyclists, pedestrians, vehicles, and road work. Video cameras are also important components which also monitor the road's traffic and can read traffic lights. Lastly, radar sensors also help monitor the vehicle's environment in order to help provide more accuracy and safety towards the technology and driving of the driverless vehicle.
Motion sensors were originally created for the demand of protection for enemy aircraft during the Second World War. Then, motion sensors started becoming more efficient for other general uses of security in public restrooms, grocery store doors, and security systems. They are also used in shopping centers, building and home alarm systems, and flood and porch lights. They're even used for more simple features such as automatic doors. Next, it led to the use of them in self-driving cars in order to give the car the same component sauceability as the human eye. Yet going back to the 1940s, it was Samuel Bagno who created one of the first applications of motion sensing. He did a lot of research to come to the creation of an ultrasonic alarm, which was a web of ultrasonic waves inside a room which was able to detect the motion of a person in that room. This idea helped him discover the first application of motion sensing.
An example of two different types of motion sensors include radar and infrared sensors. Radar sensors radiate electromagnetic energy and detect the echo which returns from reflecting objects. Contrastingly, infrared sensors have the ability to detect the radiation which is emitted from other objects, including human beings and thermal energy. Further investigating radar motion sensors, the electromagnetic energy is sent into the environment by the use of a transmitter, while a receiver is used to record the data from the reflected echo, having the ability to know if there has been any change in the environment. Yet, infrared sensors can even be made from different materials depending on their different senses of different ranges of wavelengths. Then the cell's resistance changes once an appropriate wavelength has struck one of the material cells. Therefore, the infrared radiation can be measured through the resistance of the cell. But it's more efficient for infrared sensors to detect the rapid changes in radiation due to the variety of different objects.
Interestingly, motion sensors are advancing rapidly in their usages, proven by the driverless cars technology, but also by futuristic possibilities with these sensors. This is because these sensors can possibly be worn/shown into clothing for athletes in order for these individuals to view their performances, or for nurses to have control over elderly individuals from further distances. Not only this, but motion sensors have also been predicted to be implanted in bones during surgeries in order to give the doctors better vision and monitoring in the process of dangerous repairs. Therefore, even though many of today's society does not realize it, everyone actually greatly will rely on these sensors in order to make their everyday activities more efficient.
The sensors specifically relate to physics as they use many different equations to determine the position of the car and the acceleration and the velocity at which the car should go. Furthermore, motion sensors are able to measure distances to a target by illuminating the target with a pulsed laser light. Therefore, sound waves are used to determine the distance of an object. This may include a pressure wave which travels with a certain specific speed. The speed of this wave depends on the type of gas it's traveling in and the temperature it's traveling in. They're also able to measure the reflected pulses and use the difference of wavelengths to make a digital representation of the target. Next, the pulses of these motion sensors travel at the sound and air speed, which is about 345 meters per second, depending on atmospheric conditions.
For example, if the pulses reflect off of a nearby object that is a distance d from the motion sensor, and the reflected pulse comes back to the detector after time t, It shows that this simply means distance equals rate times time, except that the distance traveled by the pulse is going to be 2d. The equation for distance is d equals vt divided by 2. Motion sensors have specific factors which allow them to work the way they do. One of these factors consists of how they calculate the position of where the car is. A general equation for this is d equals v2 divided by 2, as just stated, as d represents distance, v represents velocity, and t represents time. The motion sensor also has to focus on the position of the car. A general equation to determine velocity is v equals d2 minus d1 all over t2 minus t1.
Additionally, the acceleration is going to be the slope of the velocity versus time graph. Therefore, if you consist of having a velocity of v1 at a specific time t1 and velocity v2 at a specific time of t2, then your acceleration will relatively conclude in being v2 minus v1 all over t2 minus t1. Therefore, motion sensors are greatly responsible for the success of a driverless vehicle and play a dominant role in the substitution of a human eye. Due to the equations which determine the distance, velocity, and acceleration, these motion sensors are able to easily detect their surroundings in order to signal the car into specific actions which prevent any danger and enhance safe driving. Thank you for listening to our presentation. Hopefully you all now have a head start on these advanced innovations once they start dominating the traffic of our society.